This is Stephen, and this quantitative comparison is testing your ability to multiply polynomials. In this case, you're multiplying a binomial to a trinomial, or a two-part expression to a three-part expression. The nice thing is, with column B, x to the third power minus y to the third power is all that it can be. So we need to try and get column A to do or seem like column B. Now, your first inclination might be to say that the relationships cannot be determined, but let's see if we can't reduce this down some. So if we have x minus y times x squared plus xy plus y squared, we're basically going to be multiplying this x value to each of these things in turn. And it works the same way as FOIL. With binomials, you're doing the same thing with this binomial and trinomial. And then you multiply the y to each of these things. Another way of writing this out is starting with x times x squared plus xy plus y squared minus y, because it's a negative y here, times the same thing, x squared plus xy plus y squared, and then just distribute these values. So let's start with this. X times x squared is x cubed. X times xy is positive x squared y. And then x times y squared is positive x y squared. Then do the same thing for this one over here. Y, negative y times x squared is minus, clear that up so it's the same color, minus y x squared. Now here's a problem though. If we write it like this, with the y coming before the x, it's different than the rest of the expression. So let's put it in the same order. Now it's still negative because of this negative symbol, so minus x squared y. Now multiply negative y to this one, we get minus x y squared, because it's negative y times the y there, and then negative y times y squared becomes negative y cubed. Now we can simplify this expression because we have several variables or several expressions that are the same. So x cubed is all we can do, minus y cubed is all we can do. And you may be seeing where this is going at this point. But we have a positive x squared y and a negative x squared y. So because of that fact, these cancel out. Then we have a positive xy squared and a negative xy squared. Those cancel each other out. So we're left with x cubed minus y cubed. And because that's the same thing as column B, our answer is C.